All right, let's jump right in. One of the biggest hurdles in AI right now, it isn't just about having the smartest model, it's about what you feed that model. We're all basically drowning in this ocean of unstructured information, right? So the real trick, the name of the game, is turning all that chaos into something clear and useful.
So just imagine this for a second. You've got a goal you want to achieve. You've got a pile of internal documents, a handful of articles you saved from the web, maybe even some quick notes in a text file. It's a mess, just a jumble of raw context. So how in the world do you get an AI to make any sense of that?
And it's not just about making sense of it, right? It's about getting the AI to create something you can actually use, something that's structured, reliable, something you could drop right into production. That's the real puzzle we're digging into here, a system that's built to do exactly that.
Okay, so first up, let's talk about the solution. It's a system called the context engineer. And honestly, the best way to think about it is like a digital chief of staff for your AI. Its whole job is to take all that messy, raw info and prepare the perfect briefing so the AI knows exactly what to do.
Now, this isn't just some simple script, It's a whole dedicated subsystem. It takes all the stuff you give it, the docs, the URLs, your main goal, and through some really sophisticated prompting, it doesn't just spit out an answer. No, it generates these super high-quality, production-ready artifacts. And that precision, that's what makes it so incredibly powerful. So, how does it actually work? Let's peel back the layers and look at the raw ingredients the system needs to get started. It all begins with what you, the user, provide. And this is what I love about it. It really highlights how simple it is for the user. All you have to bring to the table is a clear, high-level goal. You're supporting documents, and it's important to note it only takes text-based files for security, which is smart, and a list of relevant web links. That's it. That's all you do. From there, the system completely takes over. And for all you developers out there, this is where the magic really kicks off. It's just a single, clean API endpoint. You send a post request to SOP with context, bundle up those files and URLs, and boom, the whole automated workflow starts. It's just so clean and effective.
All right, now we're getting to the heart of it, the system's real secret sauce. See, it's not just about thoughtlessly dumping all that information into an LLM and hoping for the best. The magic is in how it pieces everything together to build the perfect prompt.
The system is incredibly methodical. It follows this really careful multi-step process. First, it gives the AI a job title, basically telling it what its role is. Then, it carefully feeds in the content from your files and web links. Then, and this is so important, it adds security boundaries. And finally, it provides crystal clear instructions. Every single step is designed to get rid of any confusion.
And if you look closer at the anatomy of this smart prompt, you can see just how sophisticated it is. This is way more than just a question. It's a complete briefing package. That security and trust boundaries piece is especially brilliant. It's kind of like telling an assistant not just what to do, but, just as importantly, what not to do, all based on established security best practices.
And we're not talking about gentle suggestions here. The system injects direct, non-negotiable commands right into the prompt. Take this quote, for example. It's pulled straight from the source code. By using really strong language like must be adhered to, it forces the AI to operate with the principle of least privilege. That's a huge deal, because it dramatically cuts down the risk of the AI generating something insecure or dangerous.
Okay, so we've given the system our raw info, and it's crafted this perfect prompt. So, what do we actually get? Let's move on to the final product, the powerful, structured artifacts it generates. Because this is where the real value is, right? These are the things that speed up development and make our AI apps so much more reliable.
Without a system like this, an LLM might just spit out a giant wall of text. It could be useful, but it's a mess. The context engineer, on the other hand, takes that raw output and acts like a surgeon, carefully extracting these distinct, perfectly defined artifacts. It turns that blob of text into a usable standard operating procedure, a skill package, and a JSON schema. Think about the countless developer hours that saves.
And the system can create a whole range of these artifacts. The main one is usually the standard operating procedure, the SOP. But from there, it can spin off things like skill packages for reusing logic, state schemas for automation, task graphs for really complex workflows, and it can even do security audits. Let's just quickly touch on what a few of these are. First, you've got the SOP. This is the star of the show, really. It's a clear, numbered, step-by-step guide that anyone or any AI agent can follow to get the job done. Then there's the JSON state schema. This is a game changer for automation. It's basically a structured checklist that an AI agent can use to tick off its progress as it goes through the SOP. This makes automated processes way less prone to error.
And for bigger, more complicated goals, it can generate a task graph. This thing visually maps out all the dependencies and the flow of the work. It's perfect for planning and orchestrating those really tricky, multi-part processes.
Now look, a cool system like this is only as good as its ability to be used in the real world, in a production environment. So for our final section, let's look at how this thing is built to be secure, robust, and totally future-proof. This table gives a great overview of its built-in defenses. It validates files, so nothing malicious gets in. It enforces quotas, which stops abuse. We've already talked about the secure prompts, which are huge, and it even sanitizes URLs to protect against attacks like SSRF, where a bad link could be used to snoop around the internal network. This is a classic defense-in-depth strategy, and it's done really well.
And this part here really shows how it's designed to evolve. The whole architecture is modular. That means you can easily swap out the underlying language model, say a new one comes out, without having to rewrite everything. You can plug in new, smarter ways to understand context, and it's got a built-in evaluation framework so you can constantly test and improve its performance. It's built to last.
So, when you boil it all down, here's the key takeaway. You start with a total mess of notes and links, and you end up with 5 or more distinct, super valuable, production-ready artifacts. And it's all done automatically. This is just a massive force multiplier for any team working with AI. It lets you build more complex, more reliable systems way faster than before.
Which brings us to a final pretty big question. We've seen how this system takes absolute chaos and turns it into structured, secure, and valuable output. So is this kind of disciplined, multi-layered approach, part prompt engineer, part security guard, part project manager, is this the blueprint for how we should be building all of our reliable AI systems from now on? Definitely something to think about.